Sxxx cord rated at 300 volts indicates the line-to-ground voltage rating, not the line-to-line voltage. Understanding the difference between these voltage measurements is crucial for ensuring electrical safety and preventing equipment damage. The line-to-line voltage refers to the potential difference between any two phases in a multi-phase system, whereas the line-to-ground voltage is the potential difference between any one phase in the neutral or ground conductor. Consider a 480-volt three-phase system. In this configuration, the line-to-line voltage measured between any two of the three phases is indeed 480 volts. However, the line-to-ground voltage measured between one of the phases and the grounding conductor is approximately 277 volts. This is derived from the formula line-to-line voltage divided by the square root of 3, which in this case is 480 volts divided by approximately 1.732, resulting in 277 volts. Now, addressing the specific concern about using a 300-volt rated Sxxx cord in a 480-volt three-phase system. As established, the line-to-ground voltage in such a system is 277 volts. While this value is below the 300-volt rating of the cord, it is essential to consider safety margins and potential voltage fluctuations. Electrical codes and best practices generally recommend using cords and cables with voltage ratings that exceed the maximum expected voltage in the circuit. Firstly, the 300-volt rating may not provide sufficient headroom for voltage spikes or surges that can occur in electrical systems. These transient voltages can exceed the nominal voltage and potentially damage the cord's insulation, leading to electrical hazards. Secondly, the 300-volt rating may be based on specific testing conditions and standards. It is crucial to verify the cord's suitability for the intended application and environmental conditions. Factors such as temperature, humidity, and exposure to chemicals can affect the cord's insulation properties and reduce its voltage withstanding capability. Thirdly, using a cord with a voltage rating close to the operating voltage can increase the risk of insulation breakdown over time. Continuous exposure to high voltage stress can gradually degrade the insulation, leading to leakage currents and potential short circuits. The National Electrical Code, or NEC, provides guidelines for selecting appropriate conductors and cables for various applications. While the NEC does not specifically address Sxxx cords, it emphasizes the importance of using listed and labeled equipment that is suitable for the intended use. The NEC also requires that conductors and cables be protected against overcurrent and physical damage. In the context of a 480-volt three-phase system, it is generally recommended to use cords and cables with a voltage rating of at least 600 volts. This provides a sufficient safety margin and ensures that the cord can withstand potential voltage fluctuations and environmental factors. The 600-volt rating is a common standard for industrial and commercial applications involving three-phase power. Furthermore, it is crucial to consider the ampacity, or current carrying capacity, of the cord. The ampacity must be sufficient to handle the load current of the connected equipment without overheating. The NEC provides tables that specify the allowable ampacity of conductors based on their size, insulation type, and installation method. Selecting a cord with an inadequate ampacity can lead to overheating, insulation damage, and potential fire hazards. When choosing an Sxxx cord for a specific application, it is essential to consult the manufacturer's specifications and the relevant electrical codes. The manufacturer's specifications will provide detailed information about the cord's voltage rating, ampacity, temperature rating, and other performance characteristics. The electrical codes, such as the NEC, will provide guidance on selecting and installing electrical equipment in a safe and compliant manner. In addition to the voltage and ampacity ratings, it is also important to consider the cord's construction and flexibility. Sxxx cords are typically constructed with stranded copper conductors, which provide good flexibility and durability. The insulation material is usually a thermoplastic or thermoset compound that is resistant to abrasion, chemicals, and moisture. The cord's outer jacket provides additional protection against physical damage and environmental factors. When installing an Sxxx cord, it is important to follow the manufacturer's instructions and the relevant electrical codes. The cord should be properly supported and protected against mechanical stress. The connection should be made using approved connectors and terminals, and the cord should be grounded in accordance with the NEC requirements. Regular inspection and maintenance of Sxxx cords are essential for ensuring their continued safe operation. The cord should be inspected for signs of damage, such as cuts, abrasions, or exposed conductors. Damaged cords should be replaced immediately. The connection should be checked for tightness and corrosion. Loose or corroded connections can cause overheating and voltage drop. In summary, when dealing with a 480-volt three-phase system, the line-to-ground voltage is 277 volts, which necessitates careful consideration when selecting cords and cables. Although the 277-volt value is lower than the 300-volt rating of the Sxxx cord, opting for a cord with a higher voltage rating, such as 600 volts, is generally recommended to provide an adequate safety margin and account for potential voltage fluctuations and environmental factors. It is also important to consider the cord's opacity, construction, and flexibility, as well as to follow the manufacturer's instructions and the relevant electrical codes for installation and maintenance. Remember to always prioritize electrical safety and consult with a qualified electrician if you have any doubts or concerns. Using appropriately rated cords and cables is crucial for protecting equipment, preventing electrical hazards, and ensuring the reliable operation of electrical systems.